Hello guys, welcome to Brainwave Academy. Today I'm going to continue with the topic I've been taught you before, which is a dimension. And we have solved some dimension of physical quantities, but I'm going to continue now. Number one, the first one we're going to look at today is a dimension for density. And before you find dimension for any physical quantity, you must know the formula for that word, physical quantity. And density is what? Mass over volume. Mass over volume. And the dimension for, we know that mass is all over. Then volume is what? Length times breadth times height. And mind you, length, dimension for length is L, dimension for breadth is so L, and dimension for height is so L. Now, which means that we are going to have density is equals to mass is capital letter N, and we are going to have L times L into 3. We now have N all over L raised to power 3. Then we now have N. This is L raised to power 3. If it raise up, it will change to negative power, which is minus 3. Which means the dimension for density is N L raised to power minus 3. Then number 2. Number 2 is momentum. Momentum is the product of mass of an object and its velocity, which is mass times velocity. Mass times velocity. And we already know that velocity, the dimension of velocity is what? Lt raised to power minus 1. In my previous video, we have to get this for dimension for mass is capital letter N, while this one is Lt minus 1. This is dimension for momentum. Then 3, impulse. Impulse of a force or impulse is equal to force times time. The product of force of an object and the time taken. Which means that, and we know that force is mass times acceleration. Then times the time. And then, mind you, the dimension for mass is capital letter N. Acceleration is Lt minus 2, which means that the dimension for force now is what? Lt minus 2. Then time is what? Capital letter T. And it must have power, which is raised to power 1. Then we now have Lt minus 2, then plus 1. According to law of physics, because there's a connection between them. We now have Lt minus 2 plus 1 is minus 1. And if you look at this dimension and this one, they are the same. Which means that the dimension for momentum and the impulse are the same. Then, number 4, we have a work. Okay, I'll talk about work in my previous video. Let's say we have let's say power. Power can be expressed in terms of energy and can also be expressed in terms of what? Work. Power is work all over time. Work over time. And we know that work is equal to force times distance. Which means that I have to find the dimension for work first, which will allow me to find the dimension for what? Power. So, our dimension for work, for force, is mass times acceleration. Mass, that's capital letter M. Acceleration is what? Lt minus 2 times the distance is what? N. Which means this is raised to power, this is raised to power 1. We now have N, L, 1 plus 1. Then T raised to power minus 2. We now have N, L, 1 plus 1 is 2, T raised to power minus 2. Which means this is dimension for what? Force, for work. Then let's talk about dimension for power now, because work is related to power. We now have power is equal to work over time. What is work? Dimension for work is this. It is N L squared T raised to power minus 2 all over T raised to power 1. We now have power is equal to N L squared T raised to power minus, because this is minus 2. If this one will come up, it will change to minus 2 then minus 1, because this one will change to minus 1 when it goes up. We now have P is equal to N L squared then T raised to power minus 3. This is dimension for power. Thank you and peace out.